Hey everybody, Mr. Judson here. So we're doing integrals this semester, which means we're undoing derivatives. And so what we want to do for today is we just want to think about, what do we know in terms of trig functions? All right. So let's write down the derivatives that we know. So we know that the derivative of a sine of x is equal to a cosine of x. So if that's the case, then we know what the integral of a cosine is, right? The integral of a cosine of x dx is equal to sine of x plus c. We know that the derivative of a cosine of x is equal to a negative sine of x. So what's the integral of a sine of x dx? Well, we know what the integral of a negative sine is. That's a cosine, right? So what I need to do is I'll put a negative sign right there, and I'll put one out here, because then a negative times a negative is a positive. And so the integral of a negative sine of x is a cosine, but because of that negative right there, we get a negative cosine of x plus c. So what else do we know? Let's see, the derivative of a tangent of x. You guys go ahead and write down what the derivative is, and then write an integral for it. So derivative of a tangent is a secant squared of x. So that must mean that an integral of a secant squared of x dx is equal to a tangent of x plus c. See, we don't have a derivative where our answer is just a secant by itself. So we're going to have to figure some things out here. But we at least, all the formulas that we do know, we know we can take the integral of those and get whatever we were taking the derivative of here. All right, so let's do another one. Let's say we've got the derivative of a cotangent of x. Let's see, that would be a negative cosecant squared of x. So if I was doing the integral of a cosecant squared of x dx, I need that negative sign to be there. So we'll multiply there by a negative and there. So again, negative times a negative is a positive, so we're back to the original problem. And so now my answer to this is just that right there, except I've got a negative sign out in front. So a negative cotangent of x plus c. Let's see, what else do we have here? We've got the derivative of a secant of x. That equals a secant x tangent x. So now what's the integral of a secant of x times a tangent of x dx? Well, that should just be this right here. And we've got one left. We know that the derivative of a cosecant of x is equal to a negative cosecant x cotangent x. So what's the integral of a cosecant of x cotangent of x dx? Well, again, I need that negative sign there. And so now what I do is when I take the integral of this, I come right back to this thing. So this would be a cosecant of x plus c. So there's our trig integration formulas. And I guess the thing that we should notice here is we haven't taken the integral of a secant or a tangent or a cosecant, or a cotangent. So we have 4 more that we're going to have to figure out still. But at least we know these based on the derivative work that we did last semester. All right. So here's a couple practice problems. All right, so before we do these, just one thing to kind of point out. I don't know if you remember this, when we took our derivatives, anytime we took a derivative of anything that started with a C, we got negative answers. I mean, this is one of the, I guess, the difficulties is how do we keep those negative signs straight? Well, with integrals, anytime our answer starts with a C, that's when we have, whoops, I missed the negative sign there. There we go. Yep, that should have been a negative cosecant x plus C. Make sure you fix that in your notes. So anytime our answer starts with a C, then we're going to have a negative sign in there. All right? Take a derivative of something that starts with a C, you get a negative answer. With your integral, if the answer starts with C, then we need that negative sign in there. All right, so let's try these 2 problems. All right, so the first one here, we know that we can bring a constant to the outside, so we got 3 times the integral of a secant squared of x dx. You know, a lot of times I'll just look at this and go, what did I just take the derivative of to get that? And it would have been the derivative of a tangent, right? So I'd have 3 times the tangent of x plus c. So remember, technically, my answer should look like that, because the answer to the integral is a tangent of x plus c, and now I need to distribute that 3, so what I get is 3 tangent of x plus 3c. But see, 3 times some constant I don't know just equals some other constant that I don't know, and so I don't have to put 3c in there, I could just put c. So usually we just go straight to that, okay? All right, over here, so what did I take the derivative of to get this? That would have been the derivative of a secant. Okay, so the integral of a secant theta tangent theta, that's going to be just a secant of theta. And let's see, what would I take the derivative of to get a negative cosecant squared? That would be the derivative of a cotangent. So plus cotangent theta plus c. Now, one thing that's really important with integrals, we talked about this yesterday, is if you want to know if you did things right, just take the derivative of what you see here. Derivative of a secant is a secant times a tangent. Derivative of a cotangent is a negative cosecant squared. I did it right. Okay? All right, so we'll see a few things today with some trig functions. All right, so one of the things they're going to ask us to do today is to solve a differential. Okay? And so really this looks like maybe a derivative that we would have gotten through implicit differentiation. Or maybe they're just writing their derivative that way. This right here is considered a solution point to that differential. And so what we're going to do is we're going to move this dx over to this side because that's where our x variables are. So I've got dy equals, I'm going to call this 2x to the 1/2 dx. And then what I want to do is I want to integrate both sides. So kind of like in algebra when we say you want to multiply one side by 2, well you got to do the same thing to the other side. You want to take the square root of this side, you got to take the square root of this side. You want to take the derivative of this side, you got to take the derivative. You want to integrate, you got to integrate. So that's what we're doing. We're just doing the same thing to both sides. Okay? And the number out in front of dy here is 1. So what I'm doing is I'm taking the integral with respect to y of a constant. So it would just be 1y is my answer. So I'll just write down y equals. Now, really this should be y plus c equals. And then over here I've got, I want to add 1 to the exponent and divide by the new exponent. So that's going to be 2x, add 1, you get 3 halves, and then divide by 3 halves, and then plus c. So let's see, if I'm dividing by a fraction, so I want to flip that over and multiply. So 2/3 times 2 would be 4/3. So I've got y plus c equals 4/3 x to the 3 halves plus c. Now, these two constants aren't the same, right? Remember, the reason we put c in there is because I took the derivative of something, and there may have been a number that I took the derivative of and got 0. Okay, I don't know what that number is, so we put plus c in there. Same thing over here. Could these two numbers be the same? I guess they could be. Are they? I have no idea. We don't know. So what I'm going to do is I'm just going to say, you know what, whatever this constant is, I'm just going to move it over here and subtract it, or add it, and get another constant over here. So I really want to write this as y equals 4/3 x to the 3 halves plus some constant. Okay, whatever this was, I moved it over and did the opposite, and whatever those add or subtract up to, I still have a constant that I don't know. All right, that's why we can do that. So now, why did they give us this point? Well, our solution point says if you plug a 4 into here, you get 12 for an answer. And the whole purpose of that is to figure out what that c value is. So we'll do this over here off to the side. I'm going to use this value and say that 12 equals 4/3 times 4 raised to the 3 halves plus c. So I'll move that 3 over and multiply. I get 36 equals 4 times 4 to the 3 halves plus c. You know, could I multiply these? I could, only because the bases are the same. When the base is the same, you add the exponent. So 1 plus 3 halves, that give me 5 halves. But probably what we should do is just move it over and divide. Let's just make the numbers smaller instead of making them more complicated. So move that 4 over and divide, you get 9 equals 4, let's see, if I take the square root of that, I would get 2. And then cube it, I would get 8. So really, this should be 8. Now I know what c is. Move that 8 over and subtract it, and I get c equals 1. So what was my solution to the differential? Y equals 4/3 x to the 3 halves plus 1. And I'm just going to leave that as a fractional exponent. No point in changing that. All right, so anytime they give us a solution point, it's there to help us figure out what that c value is. Let me give you guys one to try. So when we see this right here, h prime of t equals 8t cubed plus 5, h prime of t is really the same thing as dh over dt. And h of 1 equals -4, that's the same as saying 1 comma -4 is a solution point. So really this problem, even though it's written slightly different, it's exactly the same as the one we just did. You guys see if you can finish that up. Alright, so I'm going to start by moving this dt over to this side. So what I have is dh equals 8t cubed plus 5. Move the dt to the other side, and now I will integrate both sides. So here I'm taking the integral of 1 with respect to h. So that answer is just 1h. And that equals 8t to the 4th divided by the new exponent 4 plus 5t plus some constant. There was a constant here, but I'm going to quit writing that down because we just know that every time we do, we're going to end up moving it over here and either adding or subtracting it and getting another constant. So just having one of them there is okay. So let's see, that'll simplify down to 2t to the fourth. So h equals 2t to the fourth plus 5t plus c. And now we've got to figure out what our c value is. So our solution point was 1 comma negative 4. So I'll do this over here. At 1 comma negative 4. I'm going to plug in a negative 4. So this is kind of where our y values go. So this needs to be t comma h. All right, so h is going to be negative 4. Oops. And that equals, if I put a 1 in here, 1 to the fourth is 1, times 2, that's just 2, plus 5 times 1, plus c. So that adds up to 7. It's a positive 7. If I move it over, I got to do the opposite and subtract 7. So I'm going to get a negative 11 equals c. So our solution is this. H equals 2t to the fourth power plus 5t minus 11. All right, so I just want to give you guys a heads up on something. You know, when you get to this problem and you look at the directions, it's like, oh, this has got to be hard. Look how big that paragraph is. It's got to be hard, right? Well, no, it's what we just did. They talk about these things called slope fields, which this is a slope field. What a slope field is, it's a picture of what the slope of the tangent line looks like at each individual point. Okay? So these are just a whole bunch of slopes of tangent lines, but they're just drawing a really small piece of it. We don't even have to worry about that right now. Okay? I just need to look at this and think, okay, I'm trying to solve the differential. I'm going to move dx over. I'll take the integral of both sides, and there's my solution point. We don't even need to look at this picture. We don't even have to understand it. I'll tell you later what slope fields are, but for right now, don't worry about this. Okay? Whatever the directions say, we're just going to solve the differential using this solution point. Okay? All right. That's it. That's what we have for today. So let me get you guys a homework assignment. All right. So we're still on assignment number 1. This is Wednesday's portion. Page 255. We're going to do 29 to 36, and then also 45 to 48. These will be our trig integrals. These will be our solving the differential type problem. All right? Hey, just looking ahead, so Monday is President's Day. We'll have no assignment then, no videos, so you guys enjoy the weekend. Enjoy those 4 days. Hopefully the other teachers don't beat up on you, as nice as I am. I will see you guys on Wednesday next week. All right? I'll see you Thursday, but Wednesday next week will be our first meeting. All right, you guys, take care. Stay safe. We'll talk to you later. Bye.